Good morning, dear students. Now, today we'll start with our chapter 2. Is matter around us pure? Matter around us in our daily needs, like materials like milk, ghee, chili powder, and many other things which we are purchasing from the market, are all really pure? So, to learn about this and to know about the purity of the matter, we'll discuss in this chapter. But before that, we'll learn about the chemical classification of the matter, that is elements, compounds, and mixtures. In first chapter, we have learned about physical classification of matter, solid, liquid, and gas. So this is chemical classification, elements, compounds, mixtures. In 8th standard, you have learned somewhat about this. So now let me give some examples. Iron, gold, they are considered as elements. Water, salt, these are some examples of compounds. Soil, air are mixtures. Now why they are elements? Elements are having all the atoms identical in them. So if we take a piece of an iron, a bigger piece, and if you will hammer it out and break that bigger iron piece, the tiniest particle of that iron rod, I can say, it will be resembling, it will be exactly like the bigger iron rod. That means all the particles of the respective iron rod, even at the smaller size, is also identical, and so we can say that they are all identical for the same element. Irons, all particles will be of iron only. Copper, all particle will be of copper only. Carbon, all particle will be of carbon only. Oxygen, mercury, right? Iron and copper are solid. Carbon and oxygen is a gas, right? Iron, copper is a metal. Mercury is a metal but liquid, right? Carbon is non-metal. So I have given a different type of examples, that each of them, even in their smallest form or larger form, their smallest particles are resembling similar. Atoms of different elements are different. If I will compare the particles of iron with the particles of copper, then they are not same, they are different, right? So this is about the element, and thus we can say that elements are made up of similar atoms. Now about the compounds. In compounds, we can't say that all atoms are similar. Atoms are not identical to each other. If I will consider example of water, sugar, chalk, and sand, we know that water is made up of hydrogen and oxygen, sugar composed of carbon, hydrogen, and oxygen, chalk composed of calcium and carbon and oxygen, right? Sand composed of dust particles, silicon, quartz. So these are not similar in all means. They are combination of the different materials. So we can say compounds are not identical. Here I have given one question. Why water is considered compound? As I told, water is made up of hydrogen gas and oxygen gas. Hydrogen and oxygen are not identical, but they are combined in a proper proportion. That is 2 atoms of hydrogen, 1 atom of oxygen, right? Which makes a molecule. Please see here. I have made a dark spots that shows the hydrogen symbol, and a circular spots, hollow spots, that shows the oxygen element. Now when these two are combined, when we just combine them and pass electric current, then they will leave their own properties and will combine each other chemically to give us the water liquid. Both are gas, water is liquid. How it is formed? See here. Hollow circular oxygen and two dark spots of hydrogen is attached to it. It means this is one molecule of water which consists two hydrogen, one oxygen. And like this, many molecules as per the particles of atoms in the given sample will exist with the molecules, number of molecules in the water. So, we can say that compound is made up of two or more elements. In a compound, atoms form a group called molecule. This is called a molecule, right? There are many molecules in a compound. See here. Atoms in a molecule are tightly bound to each other chemically. It means the property of hydrogen itself, the property of oxygen itself is not now the property of the water. Hydrogen, when we will do the experiment, you will see that hydrogen supports the combustion with pop sound. Oxygen also supports the combustion. In younger classes you have learned, right? A candle burns when a glass was inverted on it till the air was present in it, and then it extinguished because there was no oxygen later on. So this is also supporting combustion. Hydrogen also supports with the bright flame but pop sound. But when the candle is brought in the liquid, it extinguishes. That means in a compound, when elements combine, their properties are vanished and new properties are taking place. So compound's property completely changes than its constituent atoms. Now we'll discuss about the mixtures. Now see here I have given example. If you will take gold, yellow in color, and silver, a shiny white appearance, when they are mixed, you will see that the mixture is not completely yellow or silvery white, but it appears yellowish and shiny white. It means both of the gold and silver, their property is not completely vanished, but they resembles their original property, right? But not attain completely new property. When we mix salt and sugar powder, both are white in color. It appears to us that yes, it is a mixed. Really, with our naked eyes, we are not able to separate the salt and sugar. But when we touch, we feel somewhat rough and somewhat smooth powder in it. And even if we taste, we will find both taste little salty and little sweet also. This also gives idea that properties retains, means it remains nearly same. It's not like compound that the property is completely vanished and new property is attained. In mixtures, what happens when two or more constituents are combined, then they resembles their properties of constituent particles. Constituent particles, it means the particles which are present in the mixture. Mixtures can be made by elements. As example of gold and silver, both are element. Mixtures can be made by compounds, sugar and salt. Sugar is a compound, salt is a compound, right? Salt is made up of different metals and non-metals like NaCl, sodium chloride, MgCl, magnesium chloride, and so on. Sugar, as I told, made up of carbon, hydrogen, oxygen, right? So, from the study of compound and mixture, it is concluded that compounds are due to chemical bonding among the constituent particles and mixtures are free of chemical bonding. They do not exactly react, so they do not exactly give chemical bonding. Now, from these studies, the scientists learned different types of experiment and they gave the idea about the types of mixture. Right? Here, I have given example. My dear students, if it is possible, you will also do this activity at your home. So, your concept about the types of mixtures will be clear. In one glass, you will take water and you will dissolve salt in it. You will not be able to find any separate boundaries of salt in the water. Right? This is, I am telling, you will have to experience it by observing the activity. Take another glass of water and please take the glass water made up of glass, मतलब कांच का ग्लास लेना, तो आपको देखने में इजी हो जाएगा. Take another glass and add sand to it. You will be able to find a separate boundary of water in which the sand particles are present. So what does this two different example tells us? In first example, water plus salt, from top to bottom, ऊपर से लेके नीचे तक, we will see the uniformity of the water salt solution. This is termed as homogeneous mixture. Homo, similar, geneous, medium. So similar medium. A mixture which has uniform composition throughout, that means from top to bottom, whatever the container you have taken, is termed as homogeneous mixture or solution. Also, sugar in water is one of the example. Heterogeneous. Hetero means different. Genes mean medium. A mixture which has non-uniform composition. Non-uniform, that is not similar, which contains distinct parts. Distinct means different. Like sand in a water, we can see different, right? So it is termed as heterogeneous mixture. Oil in a water. If you add oil in a water, you will see the water droplets will not mix with water. You can easily separately see them. So it is one of the example of heterogeneous mixture. So today